we go. So section 5.3. So in this one, we're going to be talking about asymptotes, and we're going to be focusing in on rational functions. So and here, all the questions are going to be asking you three things. What's the vertical asymptote? What's the horizontal asymptote? What are the oblique asymptotes? So again, above, I have provided you with asymptote notes. So definitely make sure that you have these in front of you, and we start going through it now. So the first two questions are going to be kind of interesting. They talk to you about transformations with these. I'm going to bypass the transformations, and we're going to have our calculator help us out with all that information. So we're going to bypass that part for right now. Okay. So with that being said, we're going to take this and put it in our calculator. Okay. Because the very first thing is it wants you to recognize a picture of this. Oops, we don't need math. Silly me. Alpha y equals, and our fraction was 2 over x plus 3. So there are two of these that are like this. So just for the very first piece, take that calculator out, and let's have it graph. Okay, so there is our rational function. Making sure. Oh, it's supposed to be a minus 3. That's why I always double check some things. Minus 3. I believe that should be the good stuff right there. Double checking again, make sure. Yep. All right. So we hit graph, and there's what it looks like. Okay. So some things I want to highlight. It looks like it's leveling out right in here. So you can see that right down here at the bottom, how it's kind of like running parallel to the x-axis. Hopefully my cursor is on there and it's running along there right there. That right there is an asymptote. Our calculators don't show them. Okay. So what you're looking at right here, this horizontal line that's right there, that is an asymptote. Okay. So that's our horizontal asymptote. And then right here, in between these two lines as they shoot up, kind of like a volcano lifting up to the sky, right in here in the middle at this x value of 3, okay, there is a vertical asymptote that's running straight up and down. Again, your calculator doesn't give you that piece, okay? So now that you know what the picture looks like, you'll go through and you'll look at the 4 diagrams, and then you'll pick the one that matches it. Okay. Then after that, it's going to ask you about what are the domain, the range, and it will ask you about what are the asymptotes. Okay. So we saw that up in here, we actually, I talked about it, had a horizontal asymptote. Horizontal asymptote is just a horizontal line that your graph will not cross. And we saw that horizontal line is running right here, horizontally at the number 1. I know it looks like it's at the number 1, but I promise you it is not actually at the number 1. It is just a little bit above it. And again, if you don't believe me, just go right into your table and you can see that all these fractions that we have here, they're all bigger than 1. Okay? They're not actually at 1. Okay? It's going to get really, really close to 1, but it ain't going to touch it. And then you can see that vertical asymptote that we talked about. Again, a vertical asymptote is just a vertical line that your graph will not cross. You can see it right here at number 3, where x is 3, that it's an error. That's because that's a vertical asymptote. Okay? So we had that vertical asymptote that we can talk about now too. So the horizontal asymptote, again, we said that it was at 1. Okay? And since it is a horizontal, it is y equals. Okay, so we have a horizontal asymptote at y equals 1. And again, if we look at the graph, y equals 1 would be a line that runs right across there. Let me actually put that in for you so you can see that, because I can do that. So this red line, that is the horizontal asymptote, okay, that I was hopefully highlighting earlier for you guys. And again, this blue line is coming down and it's going to get really, really close to that line, but it's not going to cross it. It's going to get really, really close to that line, but it's not going to cross it, okay? So that's a horizontal asymptote. And then we had that vertical asymptote that's right here at 3, where the x value is 3. And that is actually how we write our vertical asymptote. X equals 3. So all horizontal asymptotes, they're written as a y equals a number. All vertical asymptotes are written as x equals a number. And again, like I said a second ago, they're going to want to talk to you about the domain and range of these. Well, the domain and range of these are going to be based off of that information that we just talked about right here. These values right here are bad values, okay? And so when we go back and look at our graph, if we want to talk about the domain of that, that means we want to know where are all the good x values, okay? Where are all the good x values? Where is it that my graph exists? Okay. So as I'm running along this graph, as it's kind of making itself, my graph exists all along this blue line, except when we get to right here. So the vertical asymptote is telling you that this is the bad number for your domain. So since we know that our vertical asymptote is x equals 3, we know that the domain then is all numbers except for 3. And again, if you remember in intermediate algebra, we kind of talked about rationals and when we found their domains, and the domain of rationals, you exclude the numbers that make the denominator 0. And this 3, if you plugged it in up here into our rational, that made the denominator 0. And so yeah, that's your domain. You know, let the vertical asymptotes help guide you on that, okay? Then there's the range, which is all about the y values. So if we look at our graph, where does our graph exist at? Well, our graph exists entirely above that red line, right? My graph doesn't go any lower than that. So we need to let our range reflect that, okay? So, and that's where the horizontal asymptote comes into play, because the horizontal asymptotes kind of control like where bad values of your rational are going to exist for the range, okay? And so our range for this guy is y greater than 1. It's not going to be equal to, because that's an asymptote, and we don't want to cross that. And if you look at our graph, our line exists entirely above that red line, okay? So that's what these first two questions in 5.3 are going to look like. You know, they're going to give you a rational, and they're going to say, use transformations to pick out the graph below. Okay, well, I'm going to use my calculator to match the graph below. I'm going to work smarter, not harder. And then from there, you can find the horizontal asymptote, the vertical asymptote by looking at the graph. And then you can also use the graph to help you find that domain and range, thinking about what we just talked about, okay? So that's like the first two questions. Everything else, I'm going to show you actually the mathematics behind finding the asymptotes of rational functions, okay? So that's what the remainder of the assignment is going to be. It's going to ask you, what is the vertical, what is the horizontal, what is the possible oblique? All right, so I've got 2 problems left. Let's do that, and then that really covers 5.3. All right, so vertical asymptotes. Vertical asymptotes are very, very easy to find. In the notes, it tells you exactly how to find those vertical asymptotes, and all you have to do is set the denominator equal to 0. So when you want to find the vertical asymptote, We're just going to take the denominator, which is x plus 3. I don't care about the numerator. And we're going to set it equal to 0. That means, though, when you do this, you need to make sure that your rational is simplified, okay? Which means that the numerator and denominator need to be factored. Numerator and denominator need to be factored. And then from there, you work with just the denominator, okay? So in this one, I didn't worry about factoring the numerator or denominator because they already were factored. Okay, there's no factoring left to do on this. So this is where those of you that have factoring, like phobias and stuff like that, you gotta get good at them. Okay, you gotta know how to factor now. Okay, because this is super important for everything that we're going to do in 5.3 and 5.4. Okay, because 5.4 we're actually going to graph rationals. So if we solve this, that means we have a vertical asymptote at x equals -3. And vertical asymptotes are equations. So it needs to say x equals -3. That is a vertical asymptote. Okay. If you do not say x equals -3 and just say it's -3, that's incorrect mathematical language. Okay. So the vertical asymptote must say x equals -3. Okay. Now the next one. In the notes, I tell you, you're either going to have a horizontal asymptote or an oblique asymptote. You don't get both. You get one or the other. Okay. One or the other. And the way that this is going to work is you need to look at the degrees of the numerator and denominator polynomial. Man, I'm having trouble speaking right now. Gosh. So you look at the numerator degree and denominator degree. Okay? So if we look at our numerator degree up here, and again, this is why you got to make sure that everything's factored. Now, this is one time where the factoring might also work against us because you might have to re-multiply out all of the numerator and all of the denominator, just so you know. Okay? You might have to re-multiply all that information out. So just to kind of give you a heads up on that. So if we look up here, my numerator degree, since I don't have to worry about multiplying anything out, is 1. Okay, so the numerator degree is 1. Denominator degree we look up here is also 1 because that's the highest power. Remember, degree means highest power in your polynomial. It should be a part of that first term as what we talked about in 5.1 and 5.2. So now we go to our notes, and there are 4 cases for the horizontal asymptote and oblique asymptote. Okay? Case 1 says the numerator degree is less than the denominator degree. So in this case, is 1 less than 1? Nope. So it's not case 1. But if it was case 1, you would have a horizontal asymptote, and it would be y equals 0. Okay? So anytime you have a case 1, the horizontal asymptote exists, no oblique, and it's always y equals 0. Case 2 says the numerator equals the denominator. And if you look here, 1 equals 1, that's the one that we have. Okay? So in case 2, it's going to be y equals the leading coefficient of the numerator and the leading coefficient of the denominator. Okay, that's what we need. So if we look up here, what's the leading coefficient of the numerator? 3. So there's your numerator number. What's the leading coefficient of the denominator? What's the number in front of the x? And that's 1. So 3 divided by 1, y equals 3. And it is a horizontal asymptote. Okay? And there it is. You wouldn't have an oblique on this one because you only have one or the other. Okay. Just talk about the other two cases. Case 3, if you're looking at the notes, it says the numerator degree is bigger than the denominator by 1. So that would have been something like this. If our numerator degree up here was a 2. See how the numerator 2 is bigger than the denominator 1 by 1. Okay? In that case, you would have an oblique asymptote, and you would need to perform long division. And I have an example of that in the notes of performing long division, I think. Let me look real quick. No, I don't. Okay, but I know in these notes, I do have an example of that. Okay. So if your numerator degree is bigger than the denominator degree by 1, then you're going to do long division, and you're going to have an oblique asymptote. Okay? Then case 4 says that you will have none of them, no horizontal, no oblique, if the numerator degree is bigger than the denominator degree by 2 or more. So say this numerator degree was 3. See, that numerator is bigger than the denominator by 2. Okay, so anytime your numerator degree is bigger than the denominator degree by 2 or more, there is no horizontal and there is no oblique. Okay? And that's all the rest of this assignment works. You know, that's all you're going to be doing. All right? So let's go over here and let's give this one a try. So go ahead and pause the video, find the vertical asymptote, and find the horizontal asymptote or oblique asymptote. Okay, so vertical asymptote. So we've got this denominator, x squared plus x minus 6 equal to 0. Okay, we need to get that factored. Actually, before we do any of this, we need to factor this whole thing, right? Yes. Good, I'm glad you agree with me. So we need to take this x cubed minus 8, and we need to factor it, and that's a cubic. If you remember factoring cubics, it's a formula, and this is a difference of cubes. And difference of cubes factor just like this, a minus b, then it's a squared plus ab plus b squared. Okay? How you find out what the a and the b are is you take the cube root of each one of those factors. So I take the cube root of the x cubed, and that gives you x. Sorry, cube root, because these are cubics. That is who we call a. You take the cube root of the 8, and that is 2, and that is who you call b up here. Okay? All you got to do is fill in. So the numerator now factors to x minus 2 and x squared plus 2x plus 4. Your denominator factors to x minus 2, x minus 3. Sorry, x plus 3. So you got to make sure that you know how to factor. And inside here, you know that the x minus 2's and the x minus 2's cancel. Okay? So what we really have left for our function that we're trying to find the asymptotes of is f of x equals x squared plus 2x plus 4 all over x plus 3. Okay? So that's what we're working with. Now we start finding those vertical and horizontal or oblique asymptotes. So vertical asymptote, to find it, all you do is take the denominator, set it equal to 0, and solve. So x equals -3. There is your vertical asymptote. And then to do the horizontal or oblique, we have to look at the degrees. So what is the numerator degree? It is the highest power, which is 2. What is the denominator degree? The highest power is right here, which is that invisible 1. So the numerator is bigger than the denominator by 2. Or sorry, by 1, because 2 is bigger than 1 by 1. So that means we're going to have an oblique asymptote. No horizontal, it will be oblique. So that means we now need to run long division. So long division. And no running synthetic division. If you know synthetic division, we have to run long division. Okay? So long division. We have x squared plus 2x plus 4. Out front, we have x plus 3. Okay? So, remember in long division, we want to get rid of this first guy. So we're going to think what times x will give us x squared, because we're always working with this. So that gives us x. So now we got to take that x and multiply it through. X plus 3. So what's x times x? X squared, which we knew was going to happen. What's x times 3? A positive 3x. And then you subtract down. So the x squareds are going to cancel out. And then we have over here 2x minus 3x. And I always write that out. 2x minus 3x. So that gives you a negative 1x. And the positive 4 trickles on down. And now we're going to repeat the process. And all we want to do now is get rid of the negative 1. So what times x will give us negative 1x? And that is a negative 1. And you stop there. We don't continue anymore because all we're looking for, if you remember in those notes, an oblique asymptote is just an equation of a line. And now you have the equation of a line right here. So our oblique asymptote is y equals x minus 1. We don't care what the remainder is. We just needed that equation of a line. So when you do long division, you're not doing it all the way through. I just need to know the first 2 pieces up above. Again, we don't care about anything else from there on out. All right? So there is our oblique asymptote. And you would say that you do not have a horizontal asymptote. And that wraps up 5.3. Enjoy.